Two datasets can have exactly the same average, yet look completely different. Likewise, two variables can appear to move together without one causing the other. That's why statisticians use variance and correlation, two of the most important tools for understanding data. In this video, we'll break down both of them and with some simple examples. Variance is a huge thing in all data and can explain data very well. It is a measure of the spread of the data from its average. A couple of examples. If you have a data set, 98, 99, 100, 101, 102, we can see that the average is 100, but with not much spread. So this will be an example of a low variance. However, if we have 20, 60, 100, 140, 180, we will still have an average of 100, but the variance would be higher, which explains the data much better than just having the average. What does the number from variance mean though? Well, take a variance of say 16, square root it, and we get 4, the standard deviation. This 4 in normal distributions has an empirical rule. 68% of the data will lie within one standard deviation of the mean. So that's plus or minus 4 in this case. I don't know where they picked 68% from, but I suppose that's what they chose. Similarly, two standard deviations, plus or minus 8 in this example from the average, is 95% of the data, and it just keeps on going from there. This is, for this reason, used a lot more in advanced statistics to identify outliers. Next up, correlation. Variance is only when we are looking at one variable. But what if we wanted to look at two? A positive correlation would be noticed when the increase in one variable at the same times that another variable increases. For example, temperature increases and ice cream sales increase at the same time. A negative correlation means an increase in one variable and at the same time the other variable will go down. So this could be temperature increases and at the same time heating bills go down. No correlation leads to no observation of change. One trap not to fall into, I have tried to dance around the wording here as to not sound like I'm saying it. However, correlation does not mean that it causes the other, as this is just not true. And it is something that people fall into the jaws of a lot. I would highly recommend looking at Tyler Vigen's spurious correlations. I have no clue if I'm saying his name correctly, but that's my guess. A very interesting look if you're looking for a little chuckle or you're just a bit nerdy. This really sends this point home that correlation does not mean causation. So we get correlation from covariance, which also measures how two variables move together, but because its values depend on its units, we normally use correlation. This is something so important in all kinds of data analysis, yet something simple for us to observe, which is great. If you learned something from this video, please like the video and subscribe to support the channel. I hope to see you in the next video.